the crest, the trough, the wavelength, and the amplitude.
This wave is a transverse wave. The particles in a transverse wave move up and down perpendicular to the direction of the wave.
This is a longitudinal wave. The areas where the particles are close together is called the compression, and the areas where they're far apart is called the rarefaction. Unlike in a transverse wave, the particles in a longitudinal wave move parallel to the energy in the wave.
These waves can also be called compressional waves.
The velocity of a wave is equal to the wavelength times the frequency. The wavelength is measured in meters, the frequency is measured in hertz, and the speed is measured in meters per second.
The lower the amplitude, the less energy there is in a wave, and vice versa.
Amplitude is the height of the wave measured from the midline to the crest. In this example, you can see that this wave has a high amplitude. In this example, you can see that the wave has a lower amplitude. The energy put into the wave directly correlates with the amplitude of the wave. Here's a graph that shows this relationship. Wavelength is the length of each wave from crest to crest or trough to trough. In this example, you can see that the wavelength is high. In this example, however, there is a lower wavelength. Here is amplitude demonstrated on a Desmos graph. This is a wave with a low amplitude, and this is a wave with a high amplitude.
In a wave with a fixed speed, the longer the wavelength, the lower the frequency, and vice versa.
For example, this wave has a higher frequency but a shorter wavelength, while this one has a lower frequency and a longer wavelength. This is wavelength demonstrated in a Desmos graph. This is a wave with a longer wavelength, and this is one with a shorter wavelength.
This graph demonstrates when there's a wave of a fixed speed. When the wavelength is higher, the frequency is lower. This graph represents the opposite, showing that when a wave has a higher frequency, it has a lower wavelength if it is of a fixed speed. You're looking at the inside of a piano. The wooden things, called the hammers, are hitting the string, which causes them to vibrate. Vibrations make sound. The tone of a sound is based on its frequency. The frequency of a wave is the amount of wavelengths that are completed in 1 second. A high note has a high frequency, and a low note has a low frequency.
And here's a graph that demonstrates what a high frequency and a low frequency looks like. The period of a wave is how long each vibration lasts for.
Period equals 1 divided by the frequency, and the frequency equals 1 divided by the period.
The period is the time it takes from the pendulum to swing from one side to the other. You can measure the period by taking 2 pi times the square root of the length of the string over the gravitational constant, which is 9.8.
In this compressional wave, the period is how long it takes for the pulse to go from one end to the other.
Speed equals frequency times wavelength.
This is a graph of speed where wavelength equals 1 and demonstrates how when the period gets higher, the speed gets lower.